Are you ready to turn raw data into intelligent insights and ace your Python machine learning certification? Today, we are diving deep into 30 exam-level practice questions that will test your knowledge of Scikit-Learn, data pre-processing, and model evaluation. In this video, we will cover Python machine learning practice questions, certification exam prep. Master the fundamentals of Python machine learning with this comprehensive practice exam guide. This video covers the essential pillars of machine learning with Python, including supervised and unsupervised learning, feature engineering, and model optimization techniques. Before we jump into question 1, make sure to hit that subscribe button and grab a notepad. Let's see how many you can get right. When handling missing values in a dataset, which technique is most likely to introduce the least amount of bias if the data is missing completely at random? MCAR. Option A, filling with the mean of the column. Option B, filling with the median of the column. Option C, dropping the rows with missing values. Option D, replacing missing values with a constant like 0. The correct answer is C. If data is missing completely at random, MCAR, dropping the rows, listwise deletion, does not bias the remaining sample, although it reduces the power of the model due to a smaller dataset. Imputing with mean or median, A and B, can artificially reduce the variance of the dataset and impact the relationships between variables, potentially leading to biased estimates in downstream analysis. Replacing with 0, D, is generally discouraged unless 0 is a meaningful value in the context of the feature. In linear regression, what is the primary goal of the ordinary least squares (OLS) method? Option A, to maximize the sum of squared residuals. Option B, to minimize the sum of squared differences between observed and predicted values. Option C, to find the median of the independent variables. Option D, to ensure that all coefficients are exactly 0. The correct answer is B. Ordinary least squares, OLS, is an optimization technique used in linear regression to find the best fitting line. It achieves this by minimizing the sum of the squares of the vertical deviations, residuals, between each data point and the fitted line. By squaring the residuals, we ensure that positive and negative errors don't cancel each other out and that larger errors are penalized more heavily. Which of the following metrics is best suited for evaluating a classification model where the classes are highly imbalanced, e.g., fraud detection? Option A, accuracy. Option B, mean absolute error. Option C, area under the precision recall curve, AUPRC. Option D, R squared. The correct answer is C. In highly imbalanced datasets, accuracy, A, is misleading because a model could predict the majority class for every instance and still achieve 99% accuracy. R squared, D, and may, B, are regression metrics. Area under the precision recall curve, AUPRC, is superior to the ROC curve in these cases because it focuses on the performance of the minority positive class, which is usually the class of interest in fraud detection or rare disease diagnosis. In k-means clustering, what does the elbow method help determine? Option A, the optimal learning rate for gradient descent. Option B, the optimal number of clusters. K. Option C, the distance between the furthest data points. Option D, the number of features to use in PCA. The correct answer is B. The elbow method is a heuristic used in cluster analysis to find the appropriate number of clusters. In a dataset, it involves plotting the within-cluster sum of squares, WCSS, against the number of clusters, K. As K increases, WCSS decreases. The elbow is the point where the rate of decrease shifts significantly, indicating that adding more clusters does not provide significantly better modeling of the data. Which encoding technique should be used for a categorical feature with many categories where there is no inherent order, e.g., US states? Option A. Label encoding. Option B. Ordinal encoding. Option C. One-hot encoding. Option D. Binary scaling. The correct answer is C. One-hot encoding creates a new binary column for each unique category. This is ideal for nominal data. No order, like US states. Label encoding. A. Or ordinal encoding. B. Would assign numerical values 1, 2, 3, which a machine learning model might interpret as having a mathematical order. E.g., state 5 is greater than state 2, leading to incorrect patterns. However, for high cardinality features, techniques like target encoding or hashing might be preferred over one-hot to avoid the curse of dimensionality. A random forest is an ensemble of decision trees. Which technique does it primarily use to improve performance and reduce overfitting? Option A. Boosting. Option B. Bagging. Bootstrap aggregating. Option C. Stochastic gradient descent. Option D. Principal component analysis. The correct answer is B. Random forest uses bagging. Bootstrap aggregating. It creates multiple subsets of the training data using replacement, bootstrapping, and trains a separate decision tree on each subset. By averaging the results of these trees, it reduces the variance of the overall model without increasing the bias, making it much more robust against overfitting compared to a single decision tree. If a model performs very well on the training data but poorly on the test data, it is said to have Option A. Low bias and high variance. Option B. High bias and low variance. Option C. Low bias and low variance. Option D. High bias and high variance. The correct answer is A. This scenario describes overfitting. Overfitting occurs when a model is too complex and learns the noise in the training data rather than the underlying pattern. This results in low bias. It fits the training data well, but high variance. It changes significantly with different data, leading to poor generalization on the test set. What is the primary function of the kernel trick in support vector machines (SVM)? Option A. To reduce the number of features in the dataset. Option B. To transform data into a higher dimensional space to make it linearly separable. Option C. To handle missing values automatically. Option D. To speed up the training of deep neural networks. The correct answer is B. The kernel trick allows SVMs to solve nonlinear classification problems by mapping the original input features into a higher dimensional feature space. In this new space, a linear hyperplane can often be used to separate classes that were not linearly separable in the original space. This is done without ever actually calculating the coordinates of the data in that higher dimensional space, which saves computational power. What happens if the learning rate in gradient descent is set too high? Option A. The model will converge to the global minimum very quickly. Option B. The model may overshoot the minimum and fail to converge. Option C. The model will automatically switch to a lower learning rate. Option D. The training process will stop immediately. The correct answer is B. The learning rate determines the size of the steps taken toward a local minimum. If the learning rate is too high, the algorithm may jump over the optimal point, overshoot, and potentially diverge, causing the loss to increase or oscillate indefinitely rather than reaching the minimum. In the k-nearest neighbors (KNN) algorithm, what does the value k represent? Option A. The number of iterations. Option B. The number of features in the dataset. Option C. The number of neighbors to consider for classification regression. Option D. The number of clusters in the data. The correct answer is C. KNN is a distance-based, lazy learning algorithm. K refers to the number of closest data points, neighbors, that the algorithm looks at to make a prediction. For classification, it takes a majority vote among the K neighbors. For regression, it typically takes the average of the neighbors' values. Which regularization technique adds the absolute value of the magnitude of coefficients as a penalty term to the loss function? Option A. L2 regularization, Ridge. Option B. L1 regularization, Lasso. Option C. Elastic net. Option D. Dropout. The correct answer is B. Lasso. Least absolute shrinkage and selection operator. Uses L1 regularization. By adding the absolute value of coefficients as a penalty, Lasso can actually shrink some coefficients to exactly 0. This makes it useful for feature selection, as it effectively removes less important features from the model. What is the main objective of principal component analysis, PCA? Option A. To increase the number of features to improve model accuracy. Option B. To predict a continuous target variable. Option C. To reduce the dimensionality of the data while retaining as much variance as possible. Option D. To classify data into discrete categories. The correct answer is C. PCA is an unsupervised technique used for dimensionality reduction. It transforms the original variables into a new set of orthogonal variables called principal components, ordered by the amount of variance they explain. This helps in simplifying models, reducing storage, and visualizing high-dimensional data without losing the core structure of the dataset. Which of the following algorithms is specifically designed for binary classification by outputting a probability between 0 and 1? Option A. Linear regression. Option B. Logistic regression. Option C. K-means. Option D. DBSCAN. The correct answer is B. Despite its name, logistic regression is a classification algorithm. It uses the sigmoid logistic function to map any real-valued number into a value between 0 and 1. This output is interpreted as the probability that a given input belongs to the default class. In a confusion matrix, what does recall measure? Option A. The proportion of actual positives that were correctly identified. Option B. The proportion of predicted positives that were actually correct. Option C. The overall accuracy of the model. Option D. The number of true negatives. The correct answer is A. Recall, also known as sensitivity, is calculated as TP plus Fn. It measures the model's ability to find all relevant cases within a dataset. High recall is critical in scenarios where missing a positive case is expensive, such as detecting cancer or identifying fraudulent transactions. How does gradient boosting differ from AdaBoost? Option A. AdaBoost uses residuals, while gradient boosting uses weighted samples. Option B. Gradient boosting uses residuals to train the next model, while AdaBoost adjusts weights of misclassified samples. Option C. Gradient boosting is a bagging technique. Option D. There is no difference between them. The correct answer is B. Both are boosting techniques, but their approach to optimization differs. AdaBoost increases the weights of observations that were misclassified by the previous learner. Gradient boosting, however, fits the new learner to the residual errors. The difference between the actual and predicted values of the previous learner, effectively performing gradient descent on the loss function. Why is feature scaling important for algorithms like KNN and SVM? Option A. It helps the model handle categorical data. Option B. These algorithms rely on distance calculations, and different scales can bias the results. Option C. It is required for decision trees to function. Option D. It increases the number of features. The correct answer is B. Algorithms like KNN, SVM, and K-means use Euclidean distance to determine similarity. If one feature has a range of 0 to 1 and another has a range of 0 to 10,000, the second feature will dominate the distance calculation regardless of its actual importance. Scaling, normalization or standardization ensures all features contribute equally to the distance metric. What is the purpose of cross-validation? Option A. To train the model on the test data. Option B. To ensure the model is as complex as possible. Option C. To assess how the results of a statistical analysis will generalize to an independent dataset. Option D. To replace the need for a training set. The correct answer is C. Cross-validation, like K-fold, involves partitioning the data into subsets, training the model on some and validating it on others. This provides a more reliable estimate of the model's performance on unseen data than a single train test split, helping to detect overfitting and ensuring the model's stability. Which criterion is commonly used by decision trees to measure the purity of a split in classification? Option A. Entropy or Gini impurity. Option B. Mean squared error. Option C. R-squared. Option D. Euclidean distance. The correct answer is A. Decision trees split data based on features that result in the purest child nodes. Gini impurity measures how often a randomly chosen element from the set would be incorrectly labeled. Entropy measures the amount of information or randomness in the data. Both are used to calculate information gain for deciding the best split point. What is a major advantage of DBSCAN over K-means clustering? Option A. DBSCAN is faster for very large datasets. Option B. DBSCAN can identify clusters of arbitrary shapes and detect noise. Option C. DBSCAN requires the user to specify the number of clusters in advance. Option D. DBSCAN always produces spherical clusters. The correct answer is B. DBSCAN. Density-based spatial clustering of applications with noise. Groups together points that are close to each other based on a density threshold. Unlike k-means, it does not assume spherical clusters and does not require you to predefine the number of clusters. It is also excellent at identifying outliers as noise points. In a neural network, what is the role of the activation function? Option A. To store the weights of the network. Option B. To introduce nonlinearity into the output of a neuron. Option C. To normalize the input data. Option D. To calculate the error of the model. The correct answer is B. Without activation functions, like ReLU or sigmoid, a neural network would just be a series of linear transformations, which is equivalent to a single linear model. Activation functions allow the network to learn complex, nonlinear patterns in the data, which is essential for tasks like image recognition or language processing. What is the curse of dimensionality? Option A. The error caused by having too few features. Option B. The phenomenon where data becomes sparse in high-dimensional space, making it difficult to find patterns. Option C. A type of bias in the data collection process. Option D. When the dataset has too many rows. The correct answer is B. As the number of features, dimensions, increases, the volume of the space increases so fast that the available data becomes sparse. This sparsity makes it difficult for algorithms to find significant patterns, and the distance between points becomes less meaningful, often leading to overfitting and high computational costs. What does a high R-squared value indicate in a regression model? Option A. The model has high bias. Option B. The model explains a high percentage of the variance in the target variable. Option C. The model is likely underfitting. Option D. The model is using too few features. The correct answer is B. R-squared, coefficient of determination, is a statistical measure that represents the proportion of the variance for a dependent variable. That's explained by an independent variable or variables in a regression model. A value of 1.0 indicates that the model explains all the variability of the response data around its mean. Which of the following is true about the F1 score? Option A. It is the arithmetic mean of precision and recall. Option B. It is the harmonic mean of precision and recall. Option C. It only considers true positives and true negatives. Option D. It is used primarily for regression problems. The correct answer is B. The F1 score is the harmonic mean of precision and recall. It provides a single score that balances both metrics. It is particularly useful when you have an uneven class distribution and you need to find a balance between finding all positive instances, recall, and ensuring that your positive predictions are correct. Precision. Why is the naive Bayes algorithm called naive? Option A. Because it is very simple to implement. Option B. Because it assumes that all features are independent of each other. Option C. Because it does not require any training data. Option D. Because it cannot handle continuous data. The correct answer is B. Naive Bayes is based on Bayes' theorem. It is called naive because it makes the strong and often unrealistic assumption that all features in the dataset are independent of each other given the class label. Despite this simplification, it performs surprisingly well for text classification and spam filtering. What is the purpose of using stochastic gradient descent, SGD, instead of standard batch gradient descent? Option A. To ensure the global minimum is always found. Option B. To speed up training by updating weights using only one or a few samples at a time. Option C. To eliminate the need for feature scaling. Option D. To reduce the variance of the model. The correct answer is B. Batch gradient descent calculates the gradient using the entire dataset, which can be extremely slow and memory-intensive for large data. SGD updates the parameters for each training example, or a small batch. This introduces noise but allows for much faster updates and can help the algorithm escape local minima. What is stacking in the context of ensemble learning? Option A. Running the same model multiple times with different seeds. Option B. Combining multiple models by using their outputs as inputs for a final metamodel. Option C. A method to reduce the number of features in a dataset. Option D. The process of cleaning the data before training. The correct answer is B. Stacking. Stacked generalization is an ensemble technique where you train multiple base models, like SVM, KNN, and decision trees, and then use another model, a meta-learner, to combine their predictions. The meta-learner learns which base model is most reliable for different types of inputs. What is the difference between grid search and random search for hyperparameter tuning? Option A. Grid search is faster than random search. Option B. Grid search exhaustively tries all combinations, while random search samples combinations randomly. Option C. Random search only works for deep learning models. Option D. Grid search is more likely to overfit than random search. The correct answer is B. Grid search defines a set of values for each hyperparameter and tests every possible combination. Random search defines a distribution for each hyperparameter and randomly picks combinations. Random search is often more efficient because it can explore a wider range of values and find a good solution faster, especially when some hyperparameters are more important than others. In principal component analysis, PCA, what do the eigenvalues represent? Option A. The direction of the new axes. Option B. The amount of variance explained by each principal component. Option C. The error rate of the transformation. Option D. The number of rows in the dataset. The correct answer is B. In PCA, the eigenvectors determine the direction of the new feature space, principal components, and the eigenvalues determine the magnitude or the amount of variance captured by that component. Larger eigenvalues correspond to principal components that explain more of the dataset's total variance. Which of the following would likely reduce high bias in a model? Option A. Adding more training data. Option B. Increasing the model complexity, e.g., adding more features or layers. Option C. Applying stronger L1 regularization. Option D. Reducing the number of features. The correct answer is B. High bias. Underfitting happens when a model is too simple to capture the underlying pattern. To reduce bias, you should increase model complexity, add more relevant features, or decrease regularization. Adding more data, usually helps with high variance. Overfitting, but doesn't necessarily solve high bias if the model is fundamentally too weak. What is the main drawback of the k-nearest neighbors (KNN) algorithm during the prediction phase? Option A. It requires a long time to train the model. Option B. It is computationally expensive and slow for large datasets because it calculates distances for every query. Option C. It is highly sensitive to the initial weights. Option D. It can only be used for binary classification. The correct answer is B. KNN is a lazy learner, meaning it does no real work during training. It just stores the data. However, during prediction, it must calculate the distance between the input point and every single point in the training set to find the neighbors. This makes it very slow and memory intensive as the size of the dataset grows. That's it for our 30-question deep dive into Python machine learning. I hope these explanations helped clarify some of the tougher concepts in ML engineering. How many did you get right? Let me know your score in the comments below. If you found this helpful, give us a thumbs up. For a complete set of practice exams and in-depth study materials, check out the full course link in the description below.